Hello, everyone. Thank you for joining us again for this month's Earth Engine virtual meetup. It's hard to believe it's already March. I'm Sabrina Zito, a geospatial consultant based near Munich in Germany. And I've hosted the Earth Engine virtual meetup since September in 2019. So thank you once again for joining us, either here in Zoom or on our YouTube. So don't forget to subscribe to our channel on YouTube so you can get updates for the next session. And every time we have a session, we'll also be recording the video and posting it there. So for some of us who might be in different time zones and this isn't the best one, you can always catch up on the video later. And feel free to leave comments. We will also pass your questions on to the presenters so that, or you can get in touch with them directly through Twitter or through the emails if they share them later. So we're really excited today to welcome Celio de Sousa, who is with NASA Goddard. And the title of our presentation today is Mainstreaming National to Global Scale Land Cover and Mangrove Mapping Using Google Earth Engine. So let me stop my screen sharing for now, and we'll be able to turn the floor over to Celio. And yeah, welcome and thank you.
Thanks. Let me see if I can share my screen. Can everybody see my presentation?
Yes, looks great.
Okay, great. Yeah, so should we start?
Yes.
All right.
Thank you.
So hello, everybody. First of all, I would like to thank Sabrina for the invitation. I'm very happy to be here and to be able to actually share a little bit about how I'm using Google Earth Engine within my project and how it is changing the course of how we do land cover and ecosystem mapping at national scales. Without further ado, my name is Celio de Sousa. I'm a research scientist at NASA Goddard here in Maryland, United States. My background is forestry, but I specialized in remote sensing of vegetation and land cover mapping. Today, Liza and I were supposed to be talking about how we are helping to mainstream land cover and mangrove mapping on national and global scales. And we would do so by talking about our individual projects. But Liza, unfortunately, had a very important interview last minute, and she will not be able to join us today. So I apologize on her behalf. So I'll be using this presentation to give you a little bit of an overview of my project that deals primarily with land cover and ecosystem extent mapping to actually help support the decision-making in African countries. All right, so right off the bat, this is what I want you to know. This is what I'll be talking for the next 15 to 20 minutes, hopefully. So we are working with 3 African countries, Liberia, Gabon, and Botswana, in partnership with Conservation International, to actually tackle one of the very first steps in accounting for ecosystem services, which is actually to map the extent of land cover. So this is just a heads up on what the presentation will be about. Okay, a little bit of background or a little bit of context in my project. So we all know that the different ecosystems, they will provide different services that are very, very important to our well-being as humans, right? So that's a no-brainer right there. And by using what they call ecosystem accounting, you can essentially gather information about the flows of the benefits that these ecosystems are actually providing to the society and to the economy over time. So what is the foundation of this ecosystem accounting framework is actually the ecosystem extent account. This account is actually measured by mapping the ecosystem distribution, or let's say the ecosystem extent, and their changes over time. So in this context, NASA partnered with Conservation International to actually develop methodology for ecosystem extent mapping. So countries like Liberia, Gabon, and Botswana can actually use to support their efforts in accounting for ecosystem services and their benefits to their economy. Here, just so you guys can meet our team. So NASA's technical team is composed by Lola Fatoyimbo, Chris Nye, and I, and where I actually lead the efforts of the land cover mapping. And the Conservation International team is composed by Miroslav Honzak and Trond Larsen. And the goal of our team, the NASA team within this partnership, is to actually offer our experience with remote sensing and Earth observations in general to support the mapping of ecosystems. And we are doing that for countries that actually pledged to include the value of nature and also the ecosystem services into their national decision-making, like Liberia, Gabon, and Botswana. Okay, so I'm talking about ecosystem extent mapping. So first of all, what is the fundamental difference between land cover and ecosystem mapping in the context of our project? So, well, essentially, an ecosystem extent map would go beyond land cover, right? So if we think about a land cover map, we often find classes like forest class, right? And within this ecosystem extent map, we would have different types of forest within that class. For instance, we would have deciduous forest, we would have evergreen forest, montane forest, dry versus humid forest. And why is this important? Because each of these types of ecosystems will have different services that they will provide to us, right? So we need to go beyond land cover. And how we are doing it. So essentially, this is done through two different work streams. So the first one is led by us, the NASA team, which is actually to produce the baseline land cover map. Here is where we use our expertise with remote sensing, Earth observation data, and of course, we are using Google Earth Engine as the main platform to achieve all that. And on the other side, we have Conservation International, where they are using generalized similarity modeling, along with species distribution data, climate data, any biophysical data to come up with the modeled ecosystem extent map. Then, in the end, we merge this modeled ecosystem extent map that Conservation International produced with our land cover map to achieve the final extent, final ecosystem extent map. Obviously, my focus here will be on our side of the deal, so we are using Google Earth Engine to produce this fundamental piece of the puzzle, which is the land cover extent map, right? So without it, we cannot have the ecosystem extent map. Without the ecosystem extent map, we cannot have, we cannot do the accounting for their services, right? So this is very important, and it is very important that we get it right. Okay, so land cover mapping. I think I'm sure everyone here has experienced this to some extent. So the old ways of doing land cover mapping would essentially have so many bottlenecks, and they're mainly related to, you know, computational power and software availability. First, for example, we would have to download all the raw Landsat scenes. We would have to actually host these scenes. So we would have to have a very good computer or a server set up. Then we would need to do lots of pre-processing of these raw scenes. We would have to do radiometric correction. We would have to do registration. We would have to stitch them all together. And then you would have to do the classification per se. So all of that would have to be done using, for example, softwares that are very, very expensive. They're not open source. And most of the time, they're very computational demanding. So here, you would have to have a very good computer or a computer lab set up with all these softwares, and this can be very expensive. And on the analysis side, we all know this takes a lot of time. And I'm speaking for experience here because I've worked with land cover mapping before 10 years ago during my master's, and the amount of time that is spent just preparing the data is enormous. So, and why am I telling you all this? Because most of these developing countries in Africa are still doing land cover mapping this way, right? So they do not have the infrastructure to do it very quickly. Some of these countries actually have to outsource the mapping to some consulting companies that can actually be very expensive too, right? And take a long time. So now, since we are proposing a new way to map ecosystems, and that of course involve land cover mapping, we certainly didn't want to impose any type of restrictions to these countries in terms of computational power or data availability, right? So we wanted our methods to be easily reproduced and above all, like free. So this is why we went the Google Earth Engine route. So we all know here how amazing Google Earth Engine is. It's free, it's powerful, it's very easy to operate. The community is incredible. Every single day there's something being discovered, something being done on a different way. So it's very easy to share knowledge. And all of this is very important for us because we want these countries to be able to continue these ecosystem mapping into their future. And they need a way that is sustainable, easy, and free. We didn't want to create a method for them to do that would require them to have like a computer lab or to do, you know, have softwares or to purchase like a huge suite of softwares that are very expensive. We didn't want any of that. So that's why we went the Google Earth Engine route. Okay, so how we are doing our land cover mapping using Google Earth Engine. So I won't be going over too much detail about it, but if you're interested to learn more, feel free to check our paper. We are describing the method that we used in that paper with 2 case studies, Liberia and Gabon. The citation is right there. I think it's pretty small. Hope you can read it, but I can share later if you're interested. So the way that I usually describe our approach is we are using already established tools and algorithms, and we are not reinventing the wheel here, right? But we are using it in a way that makes sure that we achieve the necessary level of quality for our final land cover map, because that's very important for us. So this approach has 3 main phases. So the first one is essentially preparing the data, getting a wall-to-wall cloud-free mosaic over our study area, which it's often very large because we're talking about entire countries here. The second part is the classification itself. And here is where we gave it our own spin. So essentially, we are not classifying everything at once. So we're doing class by class. So I call it binary classification because oftentimes you have outputs that are the class of interest and all the others. So it's a binary map. So the phase 2 is actually done for every single class. And once we have all these classes, we then move into the phase 3, which is the map composition and accuracy assessment. So again, phase 1 is where we prepare the cloud-free mosaic to be classified. Here, I'm just showing an example of a country that we are doing this. The details are not very relevant for the case here. I'm just explaining the main idea behind each of the phase. So here, in this phase, we just want to prepare the data to get the cloud-free mosaic to be classified. And Google Earth Engine does this in a matter of seconds, which is amazing. If we think about Botswana, which is in this example here, we would have to download, pre-process, and stitch all 41 Landsat scenes together. And that would take a lot of time. That would take ages to do it. And it is just amazing how we can do this in literally 15 seconds sometimes with Google Earth Engine. So now that we have the mosaic, we can use it in the classification process. So the classification process is done like any classification within Google Earth Engine. I think you guys are familiar with it. So we first select samples. In this case, we could use ground samples because we actually went to these countries. So we were there, we were able to select ground samples, which is really great. Most of classification approaches, they lack on ground truth data. And we were lucky to be able to go to those countries and select some samples there. And we also select samples using high resolution imagery as well. So both through Google Earth, for example, and other sources within NASA. And for each of these samples, we calculated the predictors for the random forest classifier. nothing new here. So essentially, each of these samples will carry their own spectral signature for a bunch of spectral indices that we calculated, that is shown over there in the top right. Then these samples and these spectral signatures can also help us with the masking phase. So the masking phase is one of the elements of our approach that is a little bit different. So essentially, this phase helps us to get rid of most pixels that aren't likely to be the class that we are looking at. So let's imagine an example of water bodies. So we can use the water samples and inspect their signatures to actually come up with a spectral threshold that will help us to get rid of most pixels that aren't likely to be water. So we don't have to be exact here, because actually it's very, very difficult to be exact. So we just want to get rid of most of the pixels. We don't have to get rid of every non-water pixel. So we just want to do like a refinement or reduce the size of the composite, mostly because we don't want to run the random forest for hundreds of millions of pixels each time, because we're dealing with each class individually, right? So if we can reduce the number of pixels to be classified, it's better, because it's faster, and you are not likely to run into memory errors. And this masking phase also can be done if you have other important data sets available. For example, let's say that we moved into mapping mangroves now. Mangroves will have a pretty similar spectral signature to actual forests, right? So they're green, they have lots of chlorophyll. So if you were to run the classification as it is traditionally done, like all at once, you would have lots of misclassification in between those classes, right? Because they're very spectral similar. Even though random forest is very powerful in separating the classes, you would still have speckles of mangroves way inland, and that's not right. So now, if we can isolate mangroves, let's say by using a reasonable elevation threshold, because we cannot find mangrove at higher elevations, and also we cannot find mangrove way inland. Plus, we can actually use these indices that I just mentioned to actually find a threshold to get rid of most pixels that aren't likely to be the mangrove, right? This isn't a classification. This is just a pre-classification process to help us achieve a better final output by making sure that we are not including extra pixels that may cause misclassification, right? So, and that's also help Google Earth Engine to run much faster. So now that we have a masked composite, let's say that include mangrove pixels and many others that aren't mangrove, but we got rid of most of the pixels. We're not dealing with the entire country anymore because we masked based on the threshold. That's what we are feeding into the random forest here. So this is the composite that we are classifying. So we're focusing on mangrove, right? So the output will be mangrove and other classes. So we don't care about the other classes here. So we keep the mangrove class and get rid of the rest. Great, so we are satisfied with our mangrove class, let's say. So now we go back to the original composite. We use this mangrove class just as a mask and mask the composite. So now we don't have to worry about those mangrove pixels anymore because they're just masked. Then we repeat the entire process again for the next class. So we keep the class of interest, we get rid of the rest, then we come back into the original composite, use the mangrove class and this new class as masks, hide those pixels in the composite, and then we move on to doing everything again for the next class. And we keep doing this over and over until you got them all. I know this is confusing, but if you read the paper, you would understand what I'm talking about. Also, if you have any questions, just let me know. But this is just one broad overview of how we're doing the classification class by class. And by the end, you will do this like multiple times for all the classes that you're looking at. And you will have a bunch of individual classes that will be essentially like a big jigsaw puzzle pieces, right? So here in this slide on the bottom right, sorry, there's just one example of my asset folder for Botswana. I have each class separate as an asset, right? So I have all my individual classes there. And then you move into phase 3. So the phase 3 is the map composition and accuracy assessment phase. So essentially here we're going to put all of those pieces together and they will eventually compose the final map. So it's very simple. We just have to add all the assets together to each other. And voila, you have the final map. So in this phase, we also do the independent accuracy assessment. So here, just for an example, for Botswana, as I mentioned, we went to these countries, we were able to see what we were mapping. So we were there, we collected samples, and some of the samples were used as testing and the other ones as training. But the testing samples we used to check our final map. And in this case, we got an 83% overall accuracy, which is good for a country of the size of Botswana. Yeah, this is it, you guys. So this was just an example of how we're doing land cover mapping for each of those countries. So as I mentioned, I have been working with multiple countries in Africa, namely Liberia, Gabon, and Botswana. And we have done that for each of these countries. And right now, we have the baseline land cover map for each of these nations. And as I mentioned previously, we went to these countries, we talked with the stakeholders there, we talked with some government agencies, and they are quite pleased to actually learn that something like this can be done fairly quickly. And we created very, very strong relationships with these countries and these agencies, and they're happy to support our efforts as well. They provide data sets, they provide information, and in turn, we are very happy to help them to achieve their goals, right, when it comes to ecosystem services evaluation. And remember in the beginning when I was talking about the general approach to come up with an ecosystem extent map. So essentially it's merging the Conservation International map with our map. So we accomplished that for Liberia, and the government recently formally endorsed our work as the basis for their ecosystem services evaluation at national scale, which was a massive deal for us. And as a matter of fact, NASA produced a press release about this endorsement that is scheduled for tomorrow. I wish I could share with you guys today, but it's coming out tomorrow. So they wrote a story about this. They, show videos that we've made there. It was a great overview about this entire project, this entire partnership with Conservation International. It is actually a testament of how far we've come and how happy they are with what we achieved. And also, if you're interested in having a closer look at these products for Liberia, we have a web platform that you can access. All the layers are there, and the address is on the bottom. I hope you guys can read it, but I can share later as well. Yeah, again, here we are just giving you an overview of how we're achieving these key elements to achieve the final ecosystem extent map, which is land cover mapping. And we couldn't have done without the power and of how good Google Earth Engine for this matter. So if we are to do the old ways, we wouldn't be as far as we are right now. So thanks Google Earth Engine for helping us in this. And yeah, I'm just happy to be able to bring this new, let's say, technology to these countries, and they're very, very surprised that most of them never heard about it. So they're very happy to learn that, okay, so we can train our stakeholders, we can do this ourselves, because this is very important for us. They need to be doing this into the future, and we want a methodology that is easily reproducible, that is easy to share. And now our next steps are to train them. So we have a capacity building component of our project that is really big, and that's where we are right now. So pre-pandemic times, we would go to these countries, we would have webinars, we would have training sessions there so they can reproduce or at least get acquainted with how Google Earth Engine works. And that's what we are doing right now in virtual venues. Yes, I guess this is it for me. I think I went over time. So thanks for your attention, and let me know if you have any questions.
Thank you, Celio. This was a really great presentation, and you had some comments in the chat about how nice your graphics are. So I'm sure someone will be asking some questions in a bit about the design, because it's really, really good and clear.
Thank you. Thanks.
Yeah. Let me
my screen.
Yep. Let me switch over to.
Yeah, if we need to go back to the slides, I'll just share it again.
Okay. All right. I'm gonna switch over quickly to the slido.com address. So for any of you who would like to ask questions, we are having this done through slido.com, because there are also some people watching on our live stream on YouTube. So please go to slido.com, and the event code is #EEVM. And this will take you to a place where you can post some questions. So let me switch over right now and share the correct screen. All right, so I have a poll here, and the poll is, what's your top takeaway or lesson from Celio's presentation? So let's take a look and see what people's feedback is. The power of breaking things down into steps. Yes, absolutely. That's a great one. I want to look into his pre-masking approach. Pre-masking prior to classification is super helpful. Yeah, so as we are waiting for a couple more of these takeaways to come in, Celio, what's your secret to these really nicely designed slides and graphics? Like, what is your design process here?
Well, first of all, thank you guys so much for all the compliments towards the design. So I think for me, on a personal level, I'm a very visual person. Since I was a very early student, I needed to have something very colorful, very easy to follow in terms of visual graphics. So I tend to think that everybody would benefit in that way. So, and I have a little bit of a graphic design background as well. Obviously, it's not my career, but I do have a little bit of experience in that. So I like drawing, I like making figures, I like making things, you know, a little more palatable in terms of, you know, how I present them. We all love presentations, but like a blank background with just letters and no figures doesn't sit well for me. So yeah, I like drawing stuff. That's how I do these presentations, and I try to bring that into my slides.
Awesome. Yeah, thank you. Your graphic design background definitely comes through. Presentation, fantastic work. Why did you choose Landsat over Sentinel for your classifications? That's the first question.
Yeah, that's actually a very good first question. So we chose Landsat because it was predetermined by the countries. So essentially, they are more familiar with Landsat. So we had, first of all, when we established this partnership, obviously there was a background involved, and we decided to go the Landsat route because this seems to be what these countries are more familiar with. They're not often familiar with Sentinel. And also part of this project is also to expand both backwards and into the future to see how these ecosystems are changing. So if we want to go back with Sentinel, we can, because, you know, it's up to 2013, I think, if I'm not mistaken, while Landsat, we have data that goes way beyond, you know, 1980. So yeah, so that's why we chose Landsat over Sentinel. It's more established, it's more familiar to these countries, And yeah.
Yeah, that's a great answer. So we have another question here about what was your biggest challenge in doing this project?
My biggest challenge in doing this project. So for me, right off the bat would be trying not to make things very complicated, because we want these countries to be able to reproduce. Obviously, you can do very fancy stuff with Google Earth Engine. You can use multiple data sets. You can use different algorithms. You can, bring support vector machines. You can, do object-based classifications. But the challenge for me was, okay, I want a very good final product, but I don't want the method to be very, very complicated to reproduce or very difficult to transfer. So for me, the challenge was finding the balance in between using the full potential of Google Earth Engine and also make it like simple enough that we can transfer this method similarly to these countries.
Yeah, and I think another big challenge would also be thinking about the capacity building piece that you are doing right now, in how
for
to
sure.
train people who are going to be able to keep reproducing these maps into the future to track the changes in these ecosystem covers. So there's a question here related to that, which is, how long has this project run, and have you started to see any benefits for Liberia or any of the other two countries?
Yeah, so we started this project with the 3 pilot countries 3 years ago, so essentially February 2018. As of now, Liberia is the one that we have more progress in terms of engagement with the government. We also, as I mentioned, we have the ecosystem extent map already done. So we saw benefits in this because the government of Liberia is already using our product, and also we had other researchers as well using our land cover map for other studies as well. For example, we just got a paper published today. Actually, we got the acceptance of our paper that deals with chimpanzee habitat, and they were using our map as an input for their analysis. So we are already seeing things being done with the product, and we are just hopeful that things will be the same for the next countries that we're working with.
Yeah, that's awesome to hear that there's already been immediate impact through both conservation and actual people using the results to improve their own research and work. So Allison here has a question. If you have a binary classification, i.e. presence or absence of a particular vegetation type, do you need training sites for multiple non-target features, such as building, clouds, water, etc.? Or can you just have 2 training classes?
So that's a very good question, and that's what the masking phase help us with. So if we think about the entire country, if we're running for the entire country, we would have to have training sites for the multiple classes as well, right? But since we're doing a masking phase, we're getting rid of most pixels that aren't likely to be that class. So we are reducing the number of pixels or number of classes that we have to have samples for. So when we reduce the composite, we are trying to actually reduce the number of classes that we would have to have training for. So in water, for example, it's a great example. So you have samples for water, and then if you're doing a binary map, so you would have to have samples for every other land cover class in the entire country. But now, since we're masking most of them, we're reducing the number of samples that we need to have for these classes as well. So that's why we went with this masking phase procedure to help us with that as well.
Thank you. That was a really clear and detailed answer.
Thanks.
So the next question here is, what is the advantage of field-based ground truth data versus visual interpretation of aerial imagery?
Yeah, This is an interesting question. So it really depends on where you are in the world and what classes you're looking at. So sometimes for very forested countries like Liberia, Liberia has up to 70% forest cover. For example, Gabon is over 85%. So if you're not in the ground, sometimes you cannot distinguish in between, for example, secondary forest to primary forest, right? So being on the ground helps because the high resolution imagery can only do so much for us in that sense, right? We had an experience in Botswana that we went there. We went to the Okavango Delta, and I need to confess that sometimes I thought I was seeing something with the high resolution imagery, but then I went on the field. I was like, okay, this is not grassland. This is a shrubland sort of class. So the advantage of the ground truth data is to kind of help you gauge what you're seeing on the high resolution imagery. Obviously, it's not possible to have ground truth data for everywhere. But if you have some, at least it can help you gauge what you're looking at the high resolution imagery.
Yeah, absolutely.
Yeah.
Even things like differentiating between types of shrubs can be
Yes, absolutely.
Yeah.
That is the most challenging, like different classes in terms of like how dense they are.
Mm-hmm.
So from the high resolution imagery, it's very challenging. And also sometimes you don't have high resolution imagery for that timestamp.
Mm-hmm.
And these countries are very, very cloudy.
Right.
So it's really, really hard to have high resolution imagery available. So having a ground truth, it really helps.
Yeah, awesome. So we had a question as well about using elevation. So you mentioned about using elevation as a constraint to map mangroves. Do you post-process the map based on the elevation, or do you use a masked elevation layer?
So it's just one example of how we can mask. We can think of like many different ways of doing the masking, but for mangroves, for example, I tend to use elevation early on in the process. For example, I tend to mask the original composite based on the elevation. And I do this pre-masking phase where I choose this reasonable threshold for elevation that I'm sure that I'm not excluding mangrove areas, but also not including the entire country. So I'm very reasonable in that way, but I do this very early on in the composite. I don't do after the map is produced. I do before I feed the composite into the random forest.
Thank you.
Yeah.
Yeah, and Allison has another question here. Do you have suggestions for finding GE example code beyond the Earth Engine provided examples, and best practices for sharing code with others, like GitHub, but for Earth Engine?
Yeah, so this is one of the elements that we are trying to tackle since we're moving into training and capacity building, into the capacity building element of our project. So what is the best way of sharing this? Through a repository of code, through GitHub, or what would be where we share this? So this is actually a question that I don't have an answer for. But for me, as I was talking with you, Sabrina, early before this presentation, I also started not knowing anything about Google Earth Engine, and it really helps to read. We all know that to read the develops forum and all the examples, and now people are developing tutorials as well. And for this particular project, I did an introductory tutorial for classification. Also, we use it to give like a first impression of how classification is done with Google Earth Engine to our stakeholders. So if this is something that somebody is interested, I would gladly share. But yeah, my suggestion is just keep reading and going back and forth from that developer forum. That's how I did it, and practicing a lot. Yeah.
Yeah, same here. I think when I first started and I was having to write scripts by myself for a specific region of interest, I always started with a skeleton from either one of the tutorials, one of the example scripts. And then if I had a question, I would go into the developers forum, try to look through other people's code where they had asked questions about the same, say, method or function that I was confused about, and then try to incorporate some of their solutions into my own code. And I think a relevant question here is like, how do you cite other people's code? Yeah, I would paste in like the link sometimes to that code that was shared. But yeah, that's definitely a question for how we can cite each other. And I think now Stack Overflow is also a great source of code more and more.
I think most of the code since are not published anywhere, but we want to give the creator the due credits, right? But I think what we do, at least for in my case, is just a Frankenstein of so many bits and pieces of different people codes, right? As you mentioned, so you start with the skeleton and then you learn with somebody else how they do a particular, analysis for that will be useful for us, and then you bring into your own code, and then that kind of snowballs, because since you're creating your own library of things, you can start like modifying them. But yeah, that was essentially one of my concerns as well, because in the beginning, especially in the beginning, we were using different sources to create our own, let's say, Frankenstein of a code. I tend to actually copy and link the original code, and on my tutorial as well, I just like, hey, this is the code this is part of the function that I use, for example, from the examples that are available through Google Earth Engine, or I cite someone of my colleagues as well that use to help me with the coding too. So yeah, I think we have to find a better way of doing this. Giving credit to everybody, because you guys are amazing. The entire community is just so great, and they're doing it essentially, for free. It's just like producing content that is amazing and everybody can use, and we need to give them credit for it. Yeah.
Absolutely, I absolutely agree with you. And another format that I've seen people increasingly share their code is on Medium. I've seen a few people post workflows with screenshots, examples, and code and descriptions of each step. So I think that is another place where there are a few tutorial type posts popping up. So yeah, it's really exciting to see how Earth Engine is really taking on to different medium. Yeah, actually Twitter is also a great place to connect with the community, and people like Keiko, who's on this call, I think. She posts these great Earth Engine tips, and Justin Bratton is also on there posting tutorials and so forth. So yeah, that's another place to find example code beyond what is in the code editor when you log in.
Yeah, I need to get so I can tap onto this source of information as well. Yeah, thanks for sharing it.
Yeah, absolutely. And yeah, maybe we can develop a more robust sharing approach. Allison says, yeah, that's something we need to work on, and we can definitely take this conversation further and discuss with others in the community about how to do this.
Yeah, I think, and also Google Earth Engine is relatively young, and we're still trying to figure all these things out. And I'm just happy that we can help in a way that future people or of generation of users would have like a more established, let's say, workflow of like how to share, how to do this, and with a,
Absolutely. Yeah, bit by bit, we're going to get there, I hope.
Yeah, hopefully. Yeah.
So thank you again, Celio, for this awesome presentation. Somebody asked in the chat if it would be possible to get access to your slides afterwards.
Absolutely. I'll send my slides to you, Sabrina. Can you make sure that you socialize with everybody?
Absolutely. I can post it via Google Slides as a link, so people can read it. Yeah, I can do that. So I'll paste it. I'll paste the link as well on the YouTube channel afterwards, and then on Twitter, so people can access both the video and the slides. So I'm going to
Terrific.
quickly look into the chat to see if there's anything here. Okay, looks like it's all good here. So now, thank you, Celio. I'm going to open the floor to anyone who has questions about tips, tricks, troubleshooting, just general questions about Earth Engine. Maybe we can, as a group here, help each other solve some issues that we're encountering. So if you have any questions, please feel free to post them on Slido. I'm going to give you a bit of time to think about what questions you have. And in the meantime, tell you a bit more about what's coming up next. So in April, we're really excited to have Emil Charrington, who is with Servier West Africa. He's a great science communicator. You'll find him on Twitter at BZGeo. So in the meantime, you can follow him, and we'll look forward to having him here in April. So let me switch back now to our question and answer and see if anybody has posted any questions. Okay, I don't see any questions here. Anything in the chat? Yeah, so people who are on Zoom, if you'd like to share a quick introduction and share your Twitter handles, if you're on Twitter, we can kind of stay in touch afterwards and be a part of the Earth Engine community. So yeah, I don't see any questions being posted. I'll give people maybe one more minute if you have any questions, and then we might call it a day.
Yeah.
Okay, Tim asked, are the past talks posted on YouTube? Yes, for all the talks which people have agreed for them to be recorded and posted, they are on YouTube. There were a few talks where people were, in the process of getting a paper out, and they wanted to wait until the paper was out before any of their slides were public. So some of the talks are not there, but several of them are. Yeah, okay. So I guess I don't see any questions coming up. Celio, thank you so much for your time again.
Of course, thank you guys for inviting me.
Yeah, we really appreciate the presentation and your really great explanation of the various steps in your methodology for classifying land cover. And I will also be sure to link your paper so that people can also read that.
Yeah, awesome.
Yeah, so there's a quick question here on the chat here. John is writing a thesis on flooding in Ghana using Earth Engine, and they're asking for any suggestions for articles or Earth Engine code. So what immediately comes to mind is in the code editor, there's a user interface example script where there's a slider between two different timestamps of flooding in Myanmar using SAR data. So that's something you can definitely take a look at. Definitely, some of these user interface codes also have other background code that you can use in some other places. So it's not just for demonstrating the slider, but you have some way to visualize flooding, for example, in that script. So definitely take a look at that. And yeah, I would suggest looking also on Twitter, because there's a large community there who are also studying the same question, and I'm sure you'll be able to get some good articles. All right, so that's all for today. Thank you so much once again, and I wish you all a good rest of the week. Thank you, Celio, for posting the paper here. I will copy this now and share it as well. And see you on April 14th, where we have Emil Charrington as our guest. So thank you once again, and have a great rest of the week. Bye, everyone.
Bye. Thanks, you
Bye,
guys.
Celio. Thank you.